Well, hello everybody. Here's what I need to cover with you today. I need to cover section 5-3 for those of you that were gone. Now, one of the classes did take a quiz because they did not quiz last time. The other class had already taken the quiz. So upon seeing this video, if you're in G1, you had already taken the quiz. If you was in G2, you would have missed the quiz. In 3, you would have already taken the quiz also. But here's what I need to do with you today. Not a hard day. You should have your class notes in front of you. And don't panic that there's a staple in it. We're just going to go through the first page and a half today. What I do need to teach you, though, is how to name polynomials, which is semi-review, standard form. That's the easy part. Function notation will be the hard part. So hopefully you have your notes right in front of you. Just kind of hang with me on there, and we'll go from there. Hey, just for a quick trip down memory lane, though, a function is going to be a polynomial for us if, when you look at the powers, you only see positive integers. If you see any negatives or anything like that, it's not going to be a polynomial for us. And I'll show you that on the next few slides. So look right over here. All of these are polynomials because if you look at the powers, there's a x to the 0 here and a 1 there. There's a 1 there and an x to the 0 there. So we're just going to look at the powers. There's a 2 and a 1, a 3 and a 2 and a 1. So those are going to represent polynomials. The degree of this thing is going to be a 0. The reason being, this is really 13x to the 0. The leading coefficient is a 13. Now, if it's linear, meaning a line, the degree of this thing is going to be to the first, because there's a 1 right there. So that's to the first. The leading coefficient is the number in front of the variable. So in this case, that leading coefficient is a 3. If it's a quadratic, such that when we graphed it, it would be a parabola, the degree of this is the highest number that you see, which is a 2. The leading coefficient is the number in front of the squared term, which happens to be -5. Hey, notice I'm not worrying about anything else. I'm not worried about that 3x or that -7. If it's a cubic, its degree is a 3. I don't care about the 2 and the 1 and the 0. Its leading coefficient happens to be a 4. In general, it doesn't matter what the polynomial is. We're just going to go look for the biggest power that we see, and the coefficient is the number that goes along with that. So go flip over to your next slide. Here's what I'd like to do. State if each of the following represents a polynomial, and then we're going to put it in standard form. And then we're going to state the degree and the leading coefficient. If it's not a polynomial in one variable, we won't work with it. So here's our number 1. On part A, I'm going to put this in the correct order. It is a polynomial because when I look at the powers, there's a 2, a 4, a 0, and a 3. When I put this in order then, guys, it's going to be -2x to the 4th plus 1x cubed plus 3x squared minus 7. All I did is I put it in order. The degree of this thing happens to be a 4. This is a 4th degree polynomial. The leading coefficient is the number in front of the x to the 4th. So in this case, a -2. That's the leading coefficient. That's all there is to it. Go over to your number 2. Right now, that doesn't look like a polynomial. What I need to do first is simplify it. So I'm going to FOIL this thing out real fast. So I'm going to get x times 3x. I'm going to get 3x squared minus 2x plus 15x minus 10. Now, for part A, let me put this thing in order. I got 3x squared plus 13x minus 10. For my part B, the degree of it, the degree of this would be a second degree. The leading coefficient is the number in front of the squared, which is a 3. That's all there is to this first part. Here goes my number 3. When I look at it, I need to put it in descending order. So for my part A, there's an 8, so I got negative 4x to the 8th plus 3x to the 4th plus 6x to the 3rd plus 2x. I'm hoping that you already know the degree of this. The degree of this is going to be an 8th degree polynomial. The leading coefficient then is going to be a negative 4, just the number in front of there. Here's my number 4. This thing is a polynomial because when I look at the powers, all I see are 2's and 1. But we want to work with polynomials in one variable. So I'm going to put not a polynomial in one variable. Like I said, it is a polynomial, but the reason it's not a one variable polynomial because of that negative 3xy term. Here goes my number 5. When I look at this, this is not a polynomial. The reason being, the 4 over x. You can't have a variable in the denominator. The reason being, this is really 4x to the negative 1, which is a negative exponent. But it's easier to remember, you can't have a variable in the denominator. And then here's my number 6. Let me put this thing in order. It is a polynomial because I see a 4, a 3, a 6, and a x to the 0, technically. So this becomes negative x to the 6th plus 8x to the 4th minus, whoops, let me start over again. Oh, negative plus 8x to the 4th minus 2x cubed. There we go, I was right. Plus 3. The degree of this thing is a 6. The leading coefficient, negative 1. So that's all there is to classifying polynomials. I'm going to bypass this example. We talked about it in class. It's easy. It's a real-life application of what's meant by function notation. To find the answer, all we did is we plugged 2 up here wherever we saw t. And then we get the answer. But let me scroll on to the next little piece here. Look at your number 9 through 14, and let me show you what we got going on here. Kind of tough here in a way. There's 3 functions that we're working with today. Now, we've done some of this earlier in the year. Here's the function of f. Here's the function of g. Here's the function of h. 3 different functions. You have to decide which one we're working with. So when you look at number 9, it says, hey, let's go find f of negative 5. Here's what that says. It says, go hunt down the function of f. Well, that's obviously this guy. And it says, throw away the x and plug in negative 5. So here's what it's going to look like. Since I'm working with the negative number, I'm also going to use parentheses. I'm going to have negative 5 to the 3rd plus 2 parentheses negative 5 squared minus 10 parentheses negative 5 plus 20. That's what it's going to look like if you're using one of my calculators, one of the TI-83 or 84s. If you're using your own calculator, you could still type it in that way. And we're just going to run that straight through your calculator. You might pause the video and make sure you can do this in your calculator. The answer to this happens to come out to be negative 5. Will these 2 numbers be the same? Not very often. Rest of the ones that we do won't be. So here's my h of negative 4. It says, go hunt down the function of h. Well, and you'll say, hey, there it is. It says, throw away the x and throw in a negative 4 wherever you see an x. So here's what it looks like. 2 parentheses, negative 4 squared, plus 5 parentheses, negative 4, plus 3. If you'll type it into your calculator just like that, if you're using a TI-83, it'll look like this. You can use parentheses because that calculator understands what to do with it. But if you do that, you should get 15. But that's all there is to it. Now number 11 is just a little bit different. It says 5 times whatever g of 2 is. 5 times whatever g of 2 is. So I'm going to go 5 times, I'm going to use a bracket to show you that we're going to do something different. I'm going to go hunt down the function of g, which is the middle guy, and plug in a 2. So it's going to look like 2 squared plus 3 times 2 minus 4. And then I'm going to leave that 5 out there for a second. I'm going to run this part through my calculator real fast, and I'm going to get 6. Well, to bring it home, 5 times 6 is 30. And then we have it. Hey, don't be scared if you're working with the fraction. Same thing. This says, go hunt down the function of f. And you can say, hey, there it is up front. I'm going to go parenthesis 1/2 to the third plus 2 parenthesis 1/2 squared minus 10 parenthesis 1/2 plus 20. If you run that through correctly, like I said, you can pause this video at any time and make sure. But if you run that through correctly, guys, you're going to get 15.625. Would be one of your possible answers. Okay. I'm also going to throw this out. If you plug in a number, you're going to get a number. If you plug in something with a variable, you're going to get something with a variable. So number 13 and 14, the game gets a little bit tougher. So here's my number 13. I would like to find f of 3t. Well, what does that say? It says, go hunt down the function of f, and you'll say, right, there it is. Throw away all of the x's and put parenthesis 3t. Well, here's what it's going to look like. I got parenthesis 3t to the third plus 2 parenthesis 3t squared minus 10 parenthesis 3t plus 20. Now we have to simplify this. Well, 3t to the third, 3 to the third is 27. T to the third is t to the third. When I work on this part, 3t squared, 3 times 3 is 9, so this becomes 9t squared. But I got that 2 out front, so 2 times that. So this becomes 18t squared. Then I got negative 10 times 3t becomes negative 30t plus 20. And then stop. You can't do anything else with that. But that's what it's going to look like in that case. Number 14, g of negative 4m is going to look like this. Go hunt down the function of g. It's right there in the middle. I'm going to go parenthesis negative 4m squared plus 3 parenthesis negative 4m minus 4. Now when I simplify this, negative 4 times negative 4 becomes 16m squared minus 12m minus 4. And then we got it. We'll stop right there. So there's kind of the first part. But all you're doing, guys, is you're going hunting down the name of the function and then plugging in whatever's inside the parentheses. We had done something like that earlier in the year. Here's number 15, 16, 17, and 18. They get a little tougher. And then I got a couple of slides that are not on your worksheet, but just for the extra review. So here, number 15 is a tough one. Check this one out. I'd like to find g of a squared minus 1. This is a tough little problem. To find g of a squared minus 1, here's what I got to do. I got to plug a squared minus 1 right there and an a squared minus 1 right there, because there's 2 different places for it. And since, here's what I'm going to do, I've got a squared minus 1 squared plus 3 times a squared minus 1 plus 3. Well, way we're going to handle this quantity squared, we're going to write this thing out twice. So I got a squared minus 1 times a squared minus 1 plus 3 times a squared minus 1 plus 3. Now I have to FOIL this part out right here. So a squared times a squared, 1 times 1 is 1. A squared times a squared is a to the add your exponents is 4. A squared times negative 1, I'm going to get minus a squared minus another a squared. And then negative 1 times negative 1 is positive 1. Let's distribute that 3, so I got plus 3a squared minus 3 plus 3. So a little bit of algebra there. Now go combine your like terms. There's only an a to the 4th in there, so I've got a to the 4th. A squared minus a squared and positive 3a squared gives me plus 1a squared. And then I got 1 minus 3 plus 3. Looks like I'm missing something, though. Looks like I should get a plus 1. And then we have that going. So we got everything going there. Okay, so just distribute, combine your like terms, and then we'll go get them. Here goes your number 16. We're going to find h of 3c minus 4. So this one is as tough as it's going to get. Because look at h. It says 2x squared plus 5x plus 3. So to find this, I'm going to write down the 2 out front. But now I've got to plug this 3c minus 4 there and there. So I'm going to do this to it. I'm going to write down 3c minus 4 twice. And then plus 5 times 3c minus 4 plus 3. And then I'm going to FOIL this part out. And what I would suggest, guys, leave that 2 out here. We'll distribute it at the end. Now let's FOIL this. 3c times 3c is 9c squared minus 12c minus another 12c plus 16 plus 15c minus 20 plus 3. So there's what I got going on so far. Let's distribute through here. So I've got 18c squared minus 24c minus another 24c plus 32 plus 15c minus 20 plus 3. And then go through and find all of your like terms. That's my only squared term, so I got 18c squared. When I go through and combine negative 24, positive 15, it looks like I'm going to get negative 33c. And then I'm going to combine 32, negative 20, and positive 3 and get 15. So there's what I got so far. Looking back on my number 15, that's the answer to number 16. Looking back on my number 15, I used a wrong number. I looked at h and used a 3 there, guys, when it should have been a minus 4. So let me correct that error there. Hopefully you caught it as you went. And this really should have been a minus 6. I looked at the wrong part of them there. Okay. Hey, here's my number 17 then. G of 5a minus 2. It's a little bit easier than the h one. So to find g of 5a minus 2, go hunt down the function of g. Plug in 5a minus 2 wherever you see a x. So I'm going to go 5a minus 2 times 5a minus 2. That way I know to FOIL it. Plus 3 times 5a minus 2 minus 4. I won't mess up the minus 4 this time. Let's FOIL this out. So I'm going to get 25a squared minus 10a minus another 10a plus 4. Distribute that 3 and get 15a minus 6 minus 4. And then go combine any like terms that you can find. So I've got 25a squared. There's negative 10, and positive 15. Looks like negative 5a. Positive 4, negative 6, and negative 4 make a negative 6. So there's what we got going. A lot of algebra, guys. It's one of those things, take your time and make sure you write it out and go slow on it. Here's my h of negative 4d plus 3. Boy, it's going to look like this. I've got a 2. I've got negative 4d plus 3. I'm going to write that thing out twice. Then I got plus 5 times negative 4d plus 3. And then I still got a plus 3 at the very end. Hopefully I won't run out of room here. We're going to FOIL this thing out first. So I've got a 2 out there that I'm going to use here in a little bit. Negative 4d times negative 4d is 16d squared minus 12d minus another 12d plus 9. If I keep going, I got minus 20d plus 15 plus 3. Now let's distribute this 2. So I've got 32d squared minus 24d minus another 24d plus 18 minus 20d plus 15 plus 3. Big mess there, huh? Combine any like terms that you have. So there is a 32d squared. And then go through and combine all of your d terms. Here's a negative 24. There's a negative 24. There's a negative 20. So it looks like I've got negative 68d. And then combine that 18, 15, and that 3 and get positive 36. So quite a bit of algebra there to kind of go through there. Now, the next few that I have here, they are not on your class example sheet, but I kind of just had the class do them to make sure they understood what they were doing. So I'm going to kind of click through with you just to kind of show you the setup. These were easier than the ones that we just did, by the way. F of x is 3x minus 1. G of x is x squared minus 8x plus 12. And h of x is that dang 2x squared minus 4x plus 3. To find f of 10, it's just going to look like this. 3 times 10 minus 1, and you would get 29. G of 8, you would have to go 8 squared minus 8 times 8 plus 12, so I'm going to get 12. H of negative 5, you would have a 2 parenthesis because it's negative, negative 5 squared minus 4 times negative 5 plus 3. You could grab your calculator and run that through. I should see a 50 plus 20 plus 3. I should see a 73. Okay. We didn't get to those in class, so I'm not going to worry about that one right now. I got just a few more. I got f of 2x minus 7. Well, here's what it's going to look like. Go hunt down the function of f, which is that very first one. Throw away the x and plug in parenthesis 2x minus 7. So I got 3, 2x minus 7, minus 1. When I distribute here, I got 6x minus 21 minus another one. Ending answer, 6x minus 22. To find g of x plus 5, notice that you're going to be plugging that in twice. So we're going to write that out as x plus 5 times x plus 5 minus 8 times x plus 5 plus 12. FOIL this thing out. X squared plus 10x plus another 10x plus 25. Distribute that 8 and get negative 8x minus 40 plus 12. And then go combine any like terms that you see. I spy an x squared. And then it looks like I got 10x, 20x, minus 8x, so it looks like 12x. Then it looks like I got 25 minus 40 is negative 15, plus 12 looks like a negative 3. So there you got it. I'll click through number 3 and number 4 with you, and that will conclude my video for you. If I want to find g of 5x minus 2, it's going to look like this. 5x minus 2 times 5x minus 2 minus 8 times 5x minus 2 plus 12. And then we have to FOIL that out, so I've got 25x squared minus 10x minus another 10x plus 4 minus 40x plus 16 plus 12. And then combine any like terms you have. So there's a 25x squared. Here's a negative 10, a negative 10, and a negative 40. So that looks like negative 60x. And here's a 4, a 16 makes 20, plus 12 looks like a 32. Okay, so just a ton of algebra. And then H, once again, guys, that's the hard one. So let me get me some room to work right here. And this will be my last example. Whenever there's a squared involved and a number in front of it, that's just going to mean a little more work for us. So I would like to find H of 2x plus 1. So it's going to look like this. I've got 2. Now I'm going to write down 2x plus 1 twice. And then minus 4 times 2x plus 1 plus 3. We're going to FOIL this out, so I'm going to go 2 parenthesis 4x squared plus 2x plus another 2x plus 1 minus 8x plus 4, or I meant minus 4 plus 3. Distribute, I've got 8x squared plus 4x plus 4x plus 2 minus 8x minus 4 plus 3. So a lot there. Now to bring it home, go find your like term. So there's a 8x squared. Here's a 4x, and a negative 8x. So that's 0x. So I won't even write that down. And then here's a 2 and a negative 4 makes negative 2. Plus 3 becomes plus 1. So guys, there's the lesson on section 5-3. You should also have in front of you then the assignment. Those of them that understood this assignment, they clicked right through it. So good luck on it, and come see us if you need any help.